we're gonna teach you how to make a simple circuit.
Yay!
Alright, let's start with our DC regulated power supply. DC meaning direct current. And so we currently are, you get it?
So first thing we're gonna do is plug in the power source.
Yeah! Alright, and we're gonna turn it on!
Whoa!
It's on! Okay, so these are our leads that we'll be using today. This is a banana clip, and we will input that into the power supply. And this is
Same with the red.
yes, negative and positive. And this is an alligator clip, which we will use to connect the resistor to the circuit. Come on, Lila. Thank you. Alright, now we have a complete circuit.
Yay! Circuit!
Alright, now you see that we have several readings, and if we change the voltage, we get both a volt reading and an amperage reading. Alright, now we're gonna read both the voltage and the amperage for the resistor.
So the first thing we're gonna do is put both the probes in.
Yes.
Hold the multimeter.
Yes, it's called a multimeter.
Alright.
Multimeter, yeah.
So we're gonna find positive probe 2, and that's gonna go on the right side because right now we're finding voltage. So it'll go on the right side, and we're gonna turn the knob to where it has the V, not to where it has the squiggly V.
Because squiggly means alternating current, while the line means direct current.
And we want to do direct current right now, so we're gonna turn it to 2 on the volt.
And when you want to measure voltage, you want to put the probes in parallel with what you're measuring. And so, Lila, you want to do this? Make sure that they touch. And we find that we get a 1.647 ohm reading.
And don't worry, you won't get shocked. So next we're gonna turn this into an ammeter.
Yeah. So when we put into milliamps, we get a sound because we were on this voltage, and we want to read amps, which is A. Okay, let's go to 200.
So
when you think of amps, think of a part. So we're gonna take it apart. Because the resistance in the multimeter is very low, so we don't want to burn that out.
So what we're gonna do is connect the negative clip with the negative probe, and take your hand and connect the positive probe with the resistor.
We get a 24.4 amp reading. Yeah.
Woo!
That's it. Goodbye.
For our data, we started by finding the amount of current using the ammeter and the potential difference across the resistor with the voltmeter. Then, we used Ohm's law. Resistance is equal to potential difference over current to find the resistance for each of our resistors. Oh, and one more thing. Make sure that your units match, and that if you're using milliamps, that you convert them to amps when you're doing your calculations. To calculate percent error, take the absolute value of the difference between the actual resistance labeled for each resistor and the value that you calculated, and divide that by the labeled resistance. Then, multiply by 100 and you have the percent. The error should be fairly small and the resistance value should be fairly close.